Thanks, Adam. This is an exciting time in the transportation engineering world. The importance of the industry is being recognized in a big way, and technological advances, such as those found in AutoCAD Civil 3D 2010 and the extended portfolio Adam introduced, open the door to new worlds that up until now engineers had only dreamed of. To start off, I want to take you on a quick tour of the new user interface in Civil 3D 2010, which offers better organization and will provide our customers with easier access to the tools and commands they need to get up and running faster. The most significant enhancement to the interface is the addition of the ribbon across the top of the application window. The ribbon provides a single point of access for commands and controls and organizes them in a related way so that they're easier to find and use. In this drawing, you're going to see a roadway centerline or an alignment in plan view. So not only does the ribbon organize commands into related groups, but it updates based on context. For example, I can select the alignment from my drawing, and the ribbon automatically updates with a set of commands specific to alignments. This context-sensitive menu layout helps reduce the time spent searching for commands in pull-down menus and helps users become productive more quickly. Customers that work with multiple Autodesk software products will benefit from a consistent look and feel across many of the products in the portfolio so that moving between applications won't be like learning a new language. The time savings gained from these interface changes may seem trivial at first, but if you multiply them across every operation performed by a user over the course of a day or week, the potential for productivity gains becomes clear. Now let's explore some of the innovations in AutoCAD Civil 3D 2010 for transportation engineering projects. Typically, when people think about transportation projects, they envision large new construction type projects. You know, the type of project involving additional miles of state highways, interstate, tollways. While these projects do make the headlines, they're not representative of what transportation engineers typically see in practice. The most common type of project is a roadway rehabilitation, which according to the U.S. DOT accounts for over 50% of the money spent on transportation infrastructure projects. What I'm going to show you today is a rehabilitation project that involves the reconfiguration of the two intersections shown here. This example has two parts. First, the distance between the two intersections does not meet minimum standards, so one of them will be replaced with an overpass bridge to allow traffic to flow under the highway. The second part of the project involves upgrading and reconfiguring the other intersection to meet current standards. We'll start by looking at the intersection upgrade. To design the at-grade intersection, we will use the powerful new intersection design features in Civil 3D 2010. These new tools help streamline how engineers work and make intersection modeling more flexible and configurable. They will help engineers quickly iterate through different intersection options and help streamlining a complicated workflow that sometimes took days to accomplish into only minutes. One of the U.S. State Department of Transportation we are currently working with shared with me their workflow for designing a typical intersection. The workflow is 38 pages long and includes 33 steps. I mean, 33 steps, that's a lot of steps. Much of the time in their workflow is spent manually laying out the geometry of the intersection and trying to accurately model each individual region in 3D. Using the new intersection design features in Civil 3D 2010, that workflow can be reduced to only 4 steps. Geometry layout is wizard-driven and automates the generation of the intersection model. Needless to say, that DOT is anxious to get their hands on this new feature. So let's have a look. Intersection design in Civil 3D is initiated by simply selecting the intersection point of the two roadways and specifying which is the main road. Once these details are taken care of, the Create Intersection wizard is displayed. In the first step, setup items associated with intersections are defined. These are things such as the intersection name, a description, and the corridor type that you want to create. Step 2 is where all the geometry of the intersection is defined, including the
2 minutes lang yan, Ay, 1 minute lang
curves that connect the roadways in all 4 quadrants. The process is made easier by visual cues in the drawing that guide your way as you make inputs. The third step involves selecting assemblies, or simply put, the building blocks which will be used to define the 3D model of the intersection. Step 4, press the Create Intersection button. It is that simple. I know when I worked for the Wisconsin DOT, everyone wanted a Design the Road button. This new feature in Civil 3D 2010 is the closest I've seen any software come to that. The big benefit here is that the information in the intersection model is interrelated. For example, the side road profile and the main line profile are dynamically linked together. So, if I make a change in the main line profile, that change is immediately reflected in the side road profile and corridor, and so they update automatically as shown here. Now, without this capability, you would have to make all of these adjustments manually, which is incredibly time-consuming and error-prone. Beyond accelerating the design process, this new feature will help provide our customers with the ability to more quickly iterate through different intersection alternatives and layout conditions. This allows the engineer to more easily optimize the design for factors such as drainage and rideability. In the past, the process of creating the intersection model would have taken hours, maybe even days to complete. Orangewood, a Dutch company participating in our Civil 3D 2010 Gold Beta program, told me that until now, they rarely created detailed 3D intersection models because it was just too time-consuming. The CAD manager called the intersection design tool here an astonishing piece of programming and said that instead of hours, he modeled his intersections in minutes. Think about what this means in terms of cost savings. As I mentioned, intersection design is an iterative process. So with the help of Civil 3D 2010, the hours saved are multiplied by the number of iterations it takes to reach a final design. It's pretty powerful stuff. Section is complete, so we can move to the overpass. For this portion of the project, we will collaborate with our structural engineer using Autodesk Revit Structure 2010 to design the highway bridge. With the staggering numbers around the condition and safety of the world's transportation infrastructure, bridge engineers will be leading the charge around renovation, rebuilding, and new bridge construction. Autodesk Revit Structure 2010 with the Bridge Modeling Extension provides building information modeling for bridge engineers to create 3D parametric bridge structures. These parametric bridge models are valuable tools to help improve coordination, visualization, and overall understanding of bridge projects. Let's take a look at Revit Structure 2010 and the new Bridge Modeling Extension, which is a subscription benefit for Revit Structure subscription customers. The bridge engineers we talk to are looking for ways to collaborate in a more efficient and effective way with their civil engineering counterparts. One of the key features in the new Bridge Modeling Extension allows the bridge engineer to use road centerline and site condition information created by the civil engineer in Civil 3D. Sites designed by the civil engineer in Civil 3D are imported directly into Revit Structure, and this data can be used to quickly generate an accurate topographic surface for bridge modeling. This workflow drastically improves upon the 2D workflow that currently exists between civil engineers and bridge engineers. In addition to the site information, the centerline of the road from Civil 3D can also be imported directly into the Bridge Modeling Extension using the industry standard format LandXML. The centerline compiled automatically once the file is imported, providing assurance that the bridge geometry we are creating matches what the civil engineer specified in Civil 3D. The bridge engineer can now focus on defining critical layout information such as specifying the number of spans based on the overall length of the road, defining the deck properties, and defining the abutment type and location and the pier type and location. Since the road data was previously imported defining the locations of the abutments and the piers along the road, this is a simple task. With all the information from the civil engineer and the parameters defined by the bridge engineer, the bridge can be modeled instantly and we see the various views automatically updated. Now that we have our bridge modeled and the site created, we can adjust the parameters of the various bridge components to match the site conditions. A key aspect to note is that no two bridges are the same. Since all of the information for the bridge project is stored in one file, any changes made to the model are automatically propagated throughout the model, and all views such as plans, sections, details, and schedules. Using Revit structure and collaborating with civil engineers using Civil 3D, bridge engineers are equipped with a BIM solution that helps improve coordination, visualization, and overall understanding of their bridge projects. Okay, so now that the intersection and overpass have been modeled, let's look at them in the context of the overall project area. As Adam mentioned earlier, one benefit of implementing a BIM process is the ability to leverage the model for visualization. This is particularly important in the conceptual design phase of the project. Using Autodesk 3ds Max Design 2010 software and Dynamite VSP, a product from our partner 3AM Solutions, we can develop a project visualization showing the new overpass and how the highway traffic flows freely beyond it. Being able to accurately convey design intent will help reduce obstacles and objections and streamline project approval. Also, being able to visualize the project before it's built helps government agencies and community stakeholders better understand how the project will perform. Next up is the drainage network for our reconfigured intersection. Stormwater drainage analysis is a key component of the overall roadway design process and is particularly important for maintaining road safety and minimizing erosion and water quality problems. Stormwater analysis has traditionally been disconnected from the overall road design process, making it difficult for the engineer to understand the impact of design changes on drainage without rerunning the analysis each time. This is time-consuming and error-prone. High on the wish list of our transportation engineering customers is the ability to integrate stormwater analysis with roadway design. With Civil 3D 2010, the wait is over. Drainage networks can now be laid out in Civil 3D and then analyzed with an included extension that fully leverages the model. This tight integration between stormwater system layout and analysis makes it much easier for the engineer to account for stormwater drainage during design. So what I can do is once initial pipe layout is complete, the information on the proposed pipe can be sent out to be analyzed. When the analysis indicates a problem, changes are made to the updated network. And these can then be sent back to Civil 3D, or I can import them into my layout. So this more integrated approach to drainage network design and analysis will help our customers improve efficiency and quality and checks one more thing off the I wish my software could do this list. Another critical part of the transportation engineering workflow and one of the most tedious and time-consuming tasks during the production of a plan set is the calculation of pay item quantities, also known as quantity takeoff. This is typically done manually, counting items paid for individually like lampposts and performing measurements to get quantities of other items such as curb and gutter, which is paid for by the linear foot. When I worked for the Wisconsin DOT, we had teams of people focused on the task of computing quantities to prepare for bid letting. But with this time-consuming manual process comes a greater risk of errors and omissions. The new quantity takeoff functionality in Civil 3D 2010 significantly streamlines this process by extracting quantities directly from the model. Our users will be able to assign pay items to objects in the model and have the software automatically count those objects, eliminating the need for manual counting and greatly reducing the chance of error. So using the new quantity takeoff manager, pay item codes can be assigned to objects in the model. They can be assigned to objects individually. So to start, I'm going to assign a pay item to these lighting units that you see here, and I'm going to use the pay item lighting units walkway. Once I select the objects from my model, assigning pay items to them is a one-click process. No more counting and entering values in a spreadsheet. Now, as a bonus, the Quantity Takeoff Manager in Civil 3D 2010 can also be used to check that pay items have been properly assigned. So I can just come in and check it out. It shows them to me, and I know that I got all of the pay items that I wanted. This powerful new feature may seem trivial at first glance, but missed items in a cost estimate can result in expensive contract change orders in the field. When that cost comes out of your bonus at the end of the year, this no longer seems trivial. Quantity Takeoff is also integrated with roadway corridor models. So inside a corridor model, I can assign pay items to things like flow line of your curb and gutter. So any feature line, I'm going to use something like curb and gutter, so I'll just look for it here. I'm going to use this type of curb and gutter, and all I have to do is say apply, and it goes through and assigns that pay item to that linear foot of curb and gutter. The thing that our beta customers were most impressed by with this new feature is the fact that when changes are made to the corridor, the computed quantities update automatically. So the manual recalculation of quantities is virtually eliminated, and last-minute design changes don't result in hours of overtime to update quantities. Now, after pay items are assigned to objects in the model, quantity takeoffs can be computed, and different types of reports can be created, including style sheets that interface with the AASHTO transport software. The new quantity takeoff functionality in Civil 3D 2010 helps to better integrate design and construction, enabling transportation engineering teams to better prepare for bid letting in an automated fashion. The result is a more streamlined transfer of information to cost estimating software mandated by many state agencies and a decreased incident of errors and omission. Now, I'll take you back to Adam.
It's Autodesk University 2009. We're here in the AEC Lounge. I'm Ralph Bond for Autodesk. We have a special treat in store here. We're going to talk about a really interesting field trip that Trimble and Autodesk sponsored on Monday of the event. I have with us Karen Weiss, and she's going to tell us all about it. Karen, what was this field trip about?
Well, because we're focusing a lot on heavy construction and the model creation in Civil 3D and the whole, 3D modeling aspect
Right.
of everything. We've done some work with Trimble to create this importer for Trimble Business Center, a heavy construction edition. So the idea was really to show what happens with your model when you take it to construction and how far the technology has come. I mean, back when I started doing roadway design, we would create cross sections every 100 feet, and then that would get staked in the field. Well, now you cannot take that and out to the field and put it into these machines. So the whole idea was to really show what's the best way to make that model in Civil 3D so that they can just take it directly into Trimble Business Center for use on the machinery. So we looked at 3 different types of equipment. One was a motor grader. We also looked at just the total station using GPS and the rovers as well, so that everyone on the field trip got an idea of what the technology is, how the model from Civil 3D is used, and how important it is to actually create a model that is intelligent.
So you literally went out with a group of folks to a facility where you were on the computers first, sort of set the stage, and then literally went out into the field where the GPS-guided equipment did its thing. So tell us a little bit more about that process.
So what initially happened was they went out to collect the existing ground data, which they gave to me. Then I used that to create a model in Civil 3D. So we did this ahead of time, so then I could give them the model. So in the classroom, we actually talked about the model creation. I showed them exactly how I created the model, so very quick and easy. Passed that information to them, just gave them a stick. They loaded it into Trimble Business Center.
Oh, I see. So they actually did it. Okay.
Right. So then, the Trimble folks did that. They, they created the file formats that they needed. And then, yes, we took it out into the field, and they showed the motor grader actually grading this small, right in front of your eyes. You saw it go from the classroom to the field.
Now, the initial input data was from laser scanning the site. Is that correct?
I'm not 100% sure how they got their data. It might have been from laser scanning, but it's a small site, so it was very easy to get the data
Right,
in.
right.
Yeah.
But in general terms, this work we've been doing with Trimble and so forth, it does have implications for a scenario where you might be laser scanning an environment, taking this rich point cloud data. Amber Core, I know, has been working with Autodesk on making sure that data remains rich as it comes into Civil 3D, and then you can go through and then using the Trimble software solution or technology solution, do everything you were talking about on the Monday field trip, correct?
Right, correct. I mean, it's a fairly seamless process. There's no loss of data. That's the biggest thing. You want to be able to take that information, don't do any manipulation, read it directly into something like Civil 3D so that we can create the model there, have them seamlessly pull that model information out that's still intelligent, so they're getting profiles, horizontal alignments, feature lines, everything that they need then to actually give the surface to the folks in the field.
What was the reaction of the participants?
I think everyone was pretty excited. I mean, to actually see the blades moving, I mean, it's just something that you don't experience every day. I mean, you hear about it, but until you see it, you really don't understand how powerful it is, how much money it saves. I mean, the whole idea of not having to send people out there to pound stakes to do the grading, how you can take an operator who's great, and he's even greater with this technology.
Right. Well, it's changing the whole world of civil engineering and land prep. It's just remarkable. Well, thank you so much for your time.
Yeah, thank you, Ralph.